This lesson will cover Unit 3, Acquisition 3, on balancing reactions. So before we actually get to an ionic reaction, we need to talk about determining the number of atoms in a compound. Determining the number of atoms in a compound. So the first thing that you have to know is that the subscripts are equal to the number of atoms. So let's say my formula was Al2S3. These subscripts tell me the number of each atom. I have 2 aluminums and 3 sulfurs. Number 2. Subscripts in parentheses get multiplied, not added. They get multiplied. By the subscript outside the parentheses. So we're going to see this when we have an ionic compound with a polyatomic ion. Let's say I had magnesium nitrate. So here I have a subscript outside the parentheses. Just like in math class, anything in the parentheses gets multiplied by 2. Magnesium, though, is not in the parentheses, so the 2 does not go to magnesium. Magnesium does not have a subscript, so that means there's just 1 magnesium. And then this 2, just like in math, gets distributed to everything in the parentheses. So the 2 would go to nitrogen and it gets multiplied in. I have 1 nitrogen. 2 times 1 gives me 2. Again, this 2 gets multiplied in. I have 3 oxygens times 2 would give me 6 oxygens. Let's try another. Let's do aluminum sulfate. So again, the number only gets multiplied if it's in the parentheses. Aluminum is not in the parentheses, so the 3 does not get distributed to it. I have 2 aluminums. The 3 gets distributed to everything in the parentheses. So I have 1 sulfur. 1 times 3 would give me 3. I have 4 oxygens times 3. That would give me 12 oxygens. Lastly, when we balance, we're going to add something called a coefficient. And again, the coefficient is going to multiply. The coefficient multiplies the number of each atom in the compound. So let's say we had like a coefficient of 3 before calcium nitrate. This number multiplies the number of each atom. So this would go to calcium, nitrogen, and oxygen. oxygen. So in the formula I have 1 calcium, but I have 3 moles of calcium nitrate, which would give me 3 calciums. Remember, the number outside the parentheses gets multiplied in. So I have 2 nitrogens times a coefficient of 3 would give me 6. 2 times 3 gives me 6 oxygens times a coefficient of 3 would give me 18 oxygens. We can do a more simple one. Let's say I had 2 lithium oxide. Again, this 2 multiplies in. 2 times 2 would give me 4 lithiums. No subscript for oxygen, so we know there's like an imaginary 1 there. 2 times 1 would give me 2 oxygens. Let's do one more with parentheses. 2 barium phosphate. Coefficient multiplies in. 2 times 3 gives me 6. First, distribute the 2. I would have 2 phosphide ions times a coefficient of 2, which would give me 4. 2 times 4 gives me 8 oxygens times 2 would give me 16. So in order to balance reactions, you need to be able to count the number of atoms. Balancing reactions. The most important thing for balancing reactions is to know that reactions must have the same number of atoms on each side of the arrow. Law of conservation of mass. We can't just lose atoms. When we have a reaction, the left side of the arrow are the reactants. We call the right side of the arrow the products. Think of it like a recipe. Let's say we're making cookies. The reactants are like your ingredients, the flour, the sugar, the eggs, the chocolate chips, the butter. What goes in to our recipe? That's like the reactants. What goes into our reaction? The products are what comes out. Those would be your cookies, your final product. An example of a balanced reaction would be 2H2 plus O2 yields 2H2O. Coefficient multiplies in. 2 times 2 gives me 4 hydrogens. The subscript tells me I have 2 oxygens. The number of atoms on the left side of the arrow must be equal to the number on the right. 2 times 2 gives me 4 hydrogens. 2 times 1 gives me 2 oxygens. The number of atoms on the left side of the arrow must be equal to the number of atoms on the right side of the arrow. Alright, last thing before we get to some practice is how do you balance a reaction? You can only change the coefficient. never change a formula. So let's say you needed like 2 oxygens, you would not be able to like add a subscript of 2 because that would change the formula. The only thing that you can do is change the coefficients. If there is not a coefficient there, it's going to be 1. All right, first one. First one. A few suggestions or a few tips for balancing. Balance elements that appear in only one reactant and one product first. So this tip won't apply to this example, but we will use that in a few examples coming up. Next. Hydrogen and oxygen should be balanced last. Last tip, again, won't apply to this one, but we'll see it in a few examples coming up. Balance polyatomic ions as one unit. And I'll show you what I mean like that in an example coming up. So hydrogen and oxygen should be balanced last, so I'm going to start with iron. Notice that I have 2 irons on the left side, but only 1 iron on the right side. Remember, you can never change the formula. I can't add like a subscript of 2. The only way I can balance it is by changing the coefficient that comes before the formula. So 2 irons here, so I would need a 2 here. Next, I balanced my iron, so let's now go to oxygen. Here I have 3 oxygens. Here I only have 1. They need to be the same on each side. So I can add a coefficient of 3. Now I have 3 oxygens on the left, 3 oxygens on the right. Last up is hydrogen. Coefficient multiplies in, so I now have 6 hydrogens. Over here I need 6 hydrogens. I have 2 of them. So I can add a coefficient of 3. 3 times 2 gives me 6 hydrogens. 3 times 2 gives me 6 hydrogens. You could either leave this blank or you can add a number 1. Next example. This one is not ionic, but it is a good one to practice balancing. This is a combustion reaction. All right, so the reason I like to do this one is because it covers a few of these rules. Balance elements that appear in only one reactant and one product first. If you were to try to balance oxygen right away, as soon as you changed the coefficients for any of these compounds, the number of oxygens are going to change. So you'll want to do oxygen last. So let's start with Carbon. Hydrogen and oxygen should be balanced last. The only other element I have is carbon. On the left side, I have 3 carbons. Over here, I only have 1. So I can add a coefficient of 3. Next, let's do hydrogen. On the left side, I have 8 hydrogens. That means I need 8 on the right. I only have 2. Coefficients multiply in, so I'm going to put a coefficient of 4. 4 times 2 gives me 8, and here I have 8 hydrogens. For oxygen, remember, it's in multiple places. Make sure you consider oxygen from every compound. 3 times 2 gives me 6 oxygens. 4 times 1 gives me 4 oxygens. So I have a total of 10 oxygens. Here I only have 2, so my coefficient will be 5. 2 more. Sodium hydroxide plus sulfuric acid produces sodium sulfate plus water. My suggestion when you have a reaction like this is an acid-base reaction. You have hydroxide on the left and water on the right. We can rewrite this as HOH, and I'll show you why that's going to help you in just a second. All right. Hydrogen and oxygen should be balanced last. We're going to balance elements that only appear in one reactant and one product. I'm going to start with sodium. So I have 2 sodiums on the left. I need 2 sodiums on the right. So I can add a coefficient of 2 there. Balance the polyatomic ions like a unit. Hydroxide is a polyatomic ion. I have 2 hydroxides. So over here, I would need 2 hydroxides. So I can add a 2 here. Last up, we want to balance sulfate as a unit. I have 1 sulfate here, and I have 1 sulfate here. So we should be balanced. Let's go through and do a quick check. 2 sodiums, 2 sodiums. Those are balanced. Let's count the total number of oxygens. Here I have 2, and here I have 4. So that gives me 6 oxygen on the left. Well, in sulfate, I have 4 oxygens, and here I have 2. 6 oxygen. That's balanced. Let's go to hydrogen. Here I have 2 hydrogens plus 2. That would give me 4. 2 times 2 gives me 4. Hydrogen is balanced. 1 sulfur, 1 sulfur. So by separating this, you can balance the polyatomic ions as a unit. We'll do one more example with polyatomic ions. All right, so the hard thing is just trying to figure out where to start. Never start with oxygens, and then other than that, you're looking for something that is different. So I see that the aluminums are different. Starting over at the left, I only have 1 aluminum here, but I have 2 aluminums here. So I could start by adding a 2 here. Once you place your first coefficient, let it lead you. So what I mean by that is once we balance the aluminum, that now changed the number of bromines. So next, let's go balance bromine. 2 times 3 gives me 6 bromines. So I can put a 6 here and that would give me 6 bromines. Let it lead you. Now I balance the bromines, but I changed the number of potassiums. I have 6 potassiums. Over here I need 6 potassiums, so I can add a coefficient of 3. Again, balance the polyatomic ion like a unit. Here I have 3 sulfates, and here I have 3 sulfates, so this reaction is balanced.